Welcome to the ultimate masterclass in value, learning, and profitability analysis. 3 interconnected pillars that separate successful businesses from the rest. In the next 15 minutes, we'll master the analytical tools that drive strategic decision-making in today's competitive landscape. Whether you're an MBA student, business analyst, or future executive, these concepts will transform how you approach cost optimization, performance prediction, and profitability planning. By the end of this masterclass, you'll master value engineering methodology, predict performance using learning curves, and conduct comprehensive break-even analysis for strategic decision-making. These aren't just theoretical concepts. They're practical tools used daily by Fortune 500 companies, consulting firms, and innovative startups worldwide. Let's begin with the cornerstone of value optimization. Value equals function divided by cost. But this simple equation contains profound strategic implications. Traditional cost-cutting is like surgery with a chainsaw, crude and potentially damaging. Value analysis is precision surgery, eliminating only what doesn't serve the customer. Value can be enhanced through 4 strategic pathways. The Holy Grail is simultaneously enhancing functionality while reducing cost, but each pathway offers unique opportunities. Consider how smartphones evolved. Each generation offered more functionality while manufacturing costs decreased through volume and process improvements. The value analysis job plan is a systematic methodology that transforms good intentions into measurable results through 6 disciplined phases. Success requires cross-functional collaboration, bringing together design, engineering, purchasing, manufacturing, and marketing perspectives. The information phase builds the factual foundation. We gather engineering specifications, detailed cost breakdowns, and crucially, deep customer insights about what they truly value. Every cost element must be quantified and understood. Material costs, direct labor, overhead allocation. Transparency is essential for effective analysis. Function analysis is the intellectual core of value engineering. Every component's purpose is defined using exactly 2 words, an active verb and a measurable noun. Basic functions are essential. The product cannot exist without them. Secondary functions support, enhance, or arise from design choices. These are prime targets for optimization. The FAST diagram maps logical relationships between functions. Moving right answers how, moving left answers why. This reveals opportunities for elimination or combination. The creative phase unleashes uninhibited brainstorming. Judgment is suspended, unconventional ideas are celebrated, and quantity trumps immediate feasibility. For every function we ask, how else can this be accomplished? The goal is generating numerous alternatives, from incremental improvements to radical reimagining. The evaluation phase applies rigorous analysis to creative ideas. Each alternative is assessed against multiple criteria using weighted scoring models. Technical feasibility, economic impact, quality implications, and customer acceptance are all rigorously evaluated. Only ideas that pass this filter advance to development. Selected alternatives become detailed, actionable proposals. This includes new designs, supplier negotiations, cost-benefit analysis, and comprehensive implementation plans. Final proposals are presented to senior management with irrefutable business cases. Clear communication and solid data are essential for securing approval and resources. Let's apply these concepts to a real example. Consider a computer mouse. Seemingly simple, but with multiple functions and cost optimization opportunities. The basic function is detect movement and transmit signals. Secondary functions include provide comfort, resist wear, and enhance aesthetics. Each component's contribution to these functions must be evaluated. Value analysis might reveal opportunities, simpler internal mechanisms, alternative materials, or manufacturing process improvements that maintain function while reducing cost. The learning curve reveals a powerful phenomenon. As individuals and organizations repeat complex tasks, they become systematically more efficient in predictable ways. An 80% learning curve means each doubling of cumulative production reduces unit time by 20%. This isn't magic, it's the result of systematic improvement. Individual learning comes from increased familiarity, improved dexterity, reduced cognitive load, and fewer errors as workers master complex tasks. Organizational learning includes methods improvement, better tooling, optimized layouts, enhanced scheduling, and technological advancement, all contributing to efficiency gains. Product redesign often makes manufacturing easier and faster. Minor modifications can significantly impact production efficiency without compromising customer value. The learning curve follows the formula y sub x equals k times x to the power n, where y sub x is time for unit x, k is first unit time, and n is the learning index. The learning index n equals log of the learning percentage divided by log of 2. For an 80% curve, n equals negative 0.3219. Learning curves are crucial in aerospace, shipbuilding, and complex assembly industries where labor content is high and processes are intricate. For multi-unit contracts, ignoring the learning effect leads to significant cost overestimation and non-competitive pricing. Learning curves enable accurate, competitive bidding. Production scheduling becomes more realistic and efficient when learning effects are incorporated. Later units can be scheduled for faster completion. Learning curves are most effective for complex, labor-intensive tasks. In highly automated machine-paced processes, human learning opportunities are minimal. Learning effects eventually plateau as processes mature. Further improvements require major technological or process changes rather than incremental learning. Break-even analysis reveals the precise sales volume where total revenues equal total costs, the critical point where businesses transition from loss to profit. This analysis provides crucial insights for pricing strategies, cost structure decisions, product mix optimization, and capital investment evaluation. Fixed costs remain constant regardless of production volume. Rent, salaries, insurance, and depreciation must be paid whether you produce 1 unit or 1 million. Variable costs change proportionally with production volume. More units require more materials, more direct labor, and more packaging. Contribution margin is the amount from each sale available to cover fixed costs and generate profit. It's selling price minus variable cost per unit. Break-even point in units equals fixed costs divided by contribution margin per unit. In revenue terms, it's fixed costs divided by contribution margin ratio. Let's calculate. Selling price Rs 500, variable cost Rs 300 gives contribution margin Rs 200. With fixed costs, Rs 4,000,000 break-even is 20,000 units or Rs 10,000,000 revenue. The break-even chart visualizes these relationships. Fixed costs are horizontal, total costs slope upward, revenue starts at 0 and climbs. Their intersection is break-even. The area left of break-even represents losses. Costs exceed revenue. The area right of break-even represents profits. Revenue exceeds costs. Margin of safety measures how much sales can decline before reaching break-even. It's actual sales minus break-even sales, a critical risk indicator. Operating leverage reflects the proportion of fixed to variable costs. High fixed costs mean greater profit potential above break-even, but higher risk below it. Real businesses sell multiple products with different contribution margins. Break-even analysis must account for sales mix using weighted average contribution margins. Shifting toward higher margin products reduces break-even point and increases profitability. Product mix decisions have profound strategic implications. Sensitivity analysis explores what-if scenarios. How does a 10% price increase affect break-even? What about a 15% cost reduction? These insights guide strategic decisions. By modeling various scenarios, managers can assess risks and opportunities, preparing contingency plans for different market conditions. These three concepts work synergistically. Value analysis reduces costs, affecting break-even calculations. Learning curves improve efficiency, changing cost structures over time. Let's integrate these concepts through a comprehensive case study of a manufacturing company launching a new product line. Tech Manufacturing Inc. is launching a new electronic device. Initial production estimates show high costs and challenging break-even requirements. Initial analysis shows materials Rs 200, labor Rs 150, overhead Rs 100 per unit. With selling price Rs 600, contribution margin is Rs 150, Fixed costs Rs 15,000,000 require 100,000 units to break even. Value analysis reveals opportunities. Alternative materials reduce costs by Rs 30 per unit. Design simplification saves Rs 20 in labor, maintaining all essential functions. An 85% learning curve on the labor component means costs will decrease as production volume increases, improving the economic picture significantly. With value analysis improvements and learning curve effects, the break-even point drops to 75,000 units, making the project much more attractive. Let's develop your problem-solving skills through practical exercises. We'll use a systematic approach that integrates all three analytical tools. First, identify the right tool for each situation. Cost concerns suggest value analysis, repetitive processes indicate learning curves, and profitability questions require break-even analysis. Practice problem. A coffee maker costs Rs 2,500 to manufacture. Functions include heat water, brew coffee, maintain temperature, and indicate status. How would you apply value analysis? Start with function analysis. Heat water and brew coffee are basic functions. Maintain temperature and indicate status are secondary. Question each component's contribution to these functions. Opportunities might include simpler heating element design, alternative materials for the carafe, or integrated manufacturing processes that reduce assembly time. Learning curve. Problem. First unit takes 50 hours, 90%. Learning curve applies. Calculate time for units 2, 4, 8 and total time for first 16 units. Using the doubling method, Unit 2 takes 45 hours, Unit 4 takes 40.5 hours, Unit 8 takes 36.45 hours. The formula method gives the same results and works for any unit number. These calculations enable accurate cost estimation for contracts, realistic production scheduling, and proper workforce planning as efficiency improves. Break-even problem. Product sells for Rs 800, variable costs Rs 480, fixed costs Rs 6, 400,000. Calculate break-even point, margin of safety at 25,000 units, and impact of cost changes. Contribution margin is Rs 320 per unit. Break-even point is 20,000 units or Rs 16,000,000 revenue. At 25,000 units, margin of safety is 5,000 units or 20%. If variable costs decrease by Rs 30, contribution margin increases to Rs 350, reducing break-even to 18,286 units, a significant improvement in risk profile. Strategic decision-making requires integrating these tools. Value analysis optimizes costs, learning curves predict performance improvements, and break-even analysis quantifies profitability requirements. Leading companies across industries use these tools daily. Toyota's continuous improvement, Boeing's cost estimation, Apple's value engineering, all demonstrate these principles in action. Digital transformation enhances these classic tools. AI accelerates function analysis, big data improves learning curve predictions, and real-time analytics enable dynamic break-even monitoring. Future applications will incorporate sustainability metrics, circular economy principles, and digital business model considerations while maintaining these fundamental analytical frameworks. These skills open doors in management consulting, operations management, financial analysis, and strategic planning. They're essential tools for business leaders at every level. Continue developing these skills through advanced coursework, professional certifications, and practical application. Seek opportunities to apply these tools in internships and projects. Remember the essential principles. Value equals function over cost, learning curves, predict systematic improvement, and break-even analysis quantifies profitability requirements. Implementation checklist. Gather comprehensive data, involve cross-functional teams, question assumptions rigorously, and validate results through pilot testing. You now possess powerful analytical tools that drive business success. Apply them confidently, continue learning, and contribute to creating more valuable, efficient, and profitable organizations. Congratulations on completing this comprehensive masterclass. Your journey in mastering business analytics has just begun.